reflect, the other is called separate. And these patches are in a different file, and we need to reference this file first.
Could you speak up and move the patch a little more to that side so that
more like this?
Yes.
Okay. So we need to reference a different file, a file which is in the girl power folder of the pack folder, in order to get these nodes available in our patch. So I click here, go to dependencies, then add, and then you have to browse to your installation folder, somewhere here, and there's girl power, and there you will find journ, and then you take the particles to the vector inputs, VL, and then you reference this VV to the particles VL file.
We don't have the journ.
No girl power folder in the packs folder.
In the pack folder. We got VL. What? C'est d'accord. Après, il y a une patch.
Yeah, it's particles to the vector input.
Ah putain, d'accord.
Okay.
where's the deal pack?
This pack is in your installation. You're just VV installation. You're just running. We gave you in the morning. Okay. So I say, yeah, take this one. It's now referenced, and we can have a quick look in there. If I go to dependencies again, and now I see that it's referenced indeed. And then we can have a look into the void patch. Just left click. And then you will see a huge patch here, which has a couple of functions, operations. And for now we are only interested in calling this one here, the reflect on bounds. So here you see a typical utility patch. This is a stateless patch. It doesn't have any state. It's just pure functions which take some inputs, compute some stuff, and return it. No state involved here. So back to our particle. No, it's not going. So what we want to do is we want to limit the position, and somehow when the particle gets to the border of the window, it should go in another direction. And this separate operation does it already, and you should now be able to create it here. Separate. No, it's not. No, sorry, not separate. That's for later. Reflect on bounds. It's called like this. Sorry. Reflect on bounds. And it already has all the inputs and outputs you need, so we just have to connect it through.
Elias?
Take the.
Here is the reference to particle is bigger, weil was importiert hat.
Yeah, we can get to that later.
Okay.
Just go into the particle patch.
Okay.
If you can't get into the particle patch with middle click anymore, then you just open the document, and then you go to your particle patch.
Okay, I think I'm not sure if everyone has grasped this step.
So everyone has referenced this VL file, right?
Yeah.
Okay. And when you look at your mic first, then it's kind of got red and it's not working anymore.
Does everyone see in his like root patch that it's red? No? It should be red for everyone.
It should be red, yeah, for everyone. you have to somehow
Comment tu fais dependency
tell the UI to refresh.
les liens délit.
If you connect Node,
Non, attends.
if you connect the reflect on bound,
No, just referencing this file should have turned your
Oh
patch
yes, okay.
red, no?
Yeah.
Yeah.
Or some stuff.
C'est ça, tu vois, c'est un truc comme ça. Et après, voilà, tu vas dans Boss et c'est là que tu as tout le bordel. Tu delete dependency, putain, je sais plus, animation heading. Ah mais non, vas-y, faut que je retourne dans my first. Tac. Dependency.
Yeah, maybe
Security,
it's, okay. Some of you named the particle differently than others did. So the problem is why it's turning red for some of you is that this new VL file we referenced also has a particle in there. Yeah. And when we first created our own particle in the my first patch, we just said particle create. And now we have two particles create. So the reference here, it already tells us this in the error message. It tells us this, that the system found two particles. And now we have to just double click it and say, okay, I either mean this particle 2D or this particle main. The particle you patched was in the category main. And the particle we just got imported by referencing this file was in the particle, or is in the particle 2D. So to resolve this conflict, we just tell the system, okay, take the particle main. And now this one is solved here, and I do it again for the update. Also say particle main. Now your main patch or your root patch should be gray again and not red anymore.
Sorry, could you go through that?
What?
Unreading it again. Could you just go through that step again? Sorry.
So, for some of you it looks like this, right?
Yeah, yeah.
But did you get the problem?
Well, I understand the problem, I just didn't see how you solved it.
Okay, just double click it.
Double click it. Which?
And
Just anywhere, double click it.
no, on the node, on the red node. For example, this frame.
Oh, right, okay. Yeah. Lovely. Thank you. Sorry.
Okay. So everyone fixed its root patch. So
Does anyone still have a red? Which one touch? Yeah. A red light?
yeah,
Red
that's
lights are fine. You can have them or remove them if you no longer need them.
anyway. Now we can right click these nodes again and say open, and we get to the definition. And there we want to create this reflect on bounds node. And all we have to do is just to connect it through. We connect it with the position is the position, the velocity. The things are kind of mixed up. You need to read the tooltip. And so we didn't even write our velocity back. Interesting. Okay, it should look something like this in the end.
Write it back, yeah?
Should I zoom in probably?
You created a new position setter?
Yeah, I created a new velocity
Okay.
set.
Ah, yeah, velocity.
I think it's missing. I don't know if you have my patch or if you have your own. But what we want to do is, in each frame, we want to add the current velocity to our position. And then we will define here some upper and lower bounds. And this node will take care of setting clamping the position and turning the velocity. At least it should be. Okay, and I think, I'm not sure about the bounds now. We're in -1, I think. Yeah.
How is this different to the old school mapping on the mirror?
Yeah, probably not much if you look in there.
Yes, could you show where the line coming out of the bus is going?
Which one? This one?
One going straight down.
It's just the output, so we can render it, right? So we can create this transform. What it's doing differently than a regular map, right? Your question was, what is it doing differently?
How is this reflective composition different than just using the map node put on the mirror?
Probably not much, I guess. You can have a look inside what it's doing exactly. But for example, I think, if your particle goes out of the borders, it will set the position back here. And it will also turn the velocity down, because we want to bounce the particle like this. And with a regular mirror map, you won't do that. I think it will go up there and stuff like that. Ja, Joris, kannst du mal gut, geh mal rüber. Okay. Was machen wir? Hier gibt es separate points hier. Hier. Hier acceleration steht reinnehmen. Und die acceleration wird direkt mit der separate ausmachen. Acceleration of the velocity sozusagen machen. You want to see next position and the thing is before and separate.
Sorry, Defetto, it was your question was regarding the reflection? Huh? This one? Yeah.
For some reason I thought it was writing it twice. From the reflect.
No, it's velocity and position.
Yeah.
So the reflect takes care of both.
It was because of the update, the output was connected to the class update.
Okay.
What if you have two of those?
Two of what?
Position right?
It's not possible. Not in the same operation. You can, in one operation, you can only write once on a field. You can read multiple times, but write only once. Everyone there? Yeah? So the next idea was, if you're familiar with the Boyd's algorithm set of algorithms, there is like three main functionalities in the Boyd's. It's a separate, to make sure that the particles have a minimum distance to each other. And I think another one would be that they all get in the same direction, and another one. Anyway, we'll now use the separate function. And for that, we need to update our particle with another field. So we want to have the acceleration in. So we have position, velocity, and acceleration, because that's what the algorithm ladder needs. And what it also needs is, in order to be able to compute the distance to the other particles, we need to make sure that every particle gets a list of all the other particles as well. Right? So those will be the two steps. Okay, let's first add an acceleration input to the update operation of the particle. So we go to the particle and add an input here that is called acceleration. And the acceleration is typically used in like the computation of a motion by adding it up to the velocity, I think. Dottore? Velocity plus acceleration. So we have velocity plus acceleration, and then this is the new velocity, and that goes plus position.
You probably need to multiply by
To slow it down. Is it multiply?
Acceleration velocity.
I mean, it seems that we can now multiply it by 0.99 just to slow it down. To have some friction, right? Yeah, so let's do that. Here, before we add the new velocity to the position, we add some friction here. And instead of using the multiply, I would like to use the multiply scale node here. If you want to choose that, so again, type multiply, and then there is a multiply scale. That is just a scalar multiplication. So you have a single value multiplied with a vector. And that's what we need here. And then we choose adaptive again. And our friction will be something like 0.99. And now I hand back over to my colleague.
Is it still working?
No? Broken.
It's also broken. So, now here comes the more interesting part, because this is something which is always possible with every region you will ever see in this language. I mean, right now we make use of two different regions here. We make use of a loop region, which takes an input count and loops that many times, and then we have another usage of the for each region, which loops over all the input spreads or the input sequences. It doesn't have to be a spread. It can be something else, like a tree or some other stuff. Maybe we can get to that later. Anyways, right now we have spreads, and it will loop over those and do the calculation per slice inside of it. But in this case, what we want to do is give this particle all the positions of the other particles, so it can calculate so we can calculate the force for it, yeah? So how it should bounce off the other ones. So we need all the other particles for each of the particles, yeah? And you can always, and to do something like this, we can link from outside into a region. We can always link into a region, but we can't link out of a region. It's always this pattern. So it doesn't matter what region we will ever see, it's always this, you can always link into it. And this means that you somehow take that value from outside, and for each slice in there, this value will be taken and will get pushed in there. So
Kannst du nochmal den Partikel sagen?
Bei Ihnen haut es hin, gell? Okay. Do you still need it?
Yeah, it looks the same now. But
Yeah, probably you need to connect the random velocity to reflect on that. You need to reflect, you have to pass the correct velocity to the reflect on button node. From then, I mean,
Yeah. What was the difference before? Not much. Still not working. Some kind of subtle typo or something?
it's the same as when I add the acceleration.
Hmm? Yeah, I will go on, I think. So, what we want to do is we want to collect all the positions from all the particles, I say somewhere here, and then we want to put them into this loop. So we just start here and create it for each. I know that much.
hast du nochmal rauskopiert? Den Zustand dort zurückkopieren? Da muss es hin.
Okay, I can already connect the particles here. And now I get a particle inside the loop and I somehow need to get the position out without updating it again. Yeah? Okay? So the thing is, we get our old particles up here from the previous frame. We concat it with some new particles. And now we just want to fetch the position of the particle without doing the next update, because the next update we want to do down here. So we want to fetch all the positions, and then in our next update we will include those positions for our new position of each of particles. So what we have to do is we have to create a new operation inside the particle, where all we do is just simply fetch the position. So we go back into the particle, and just create a new output, we call it position. Now I don't want this position on the update operation, I want it on a separate operation which just reads out the position. So I say assign and say new operation, and I call it get position. And all that is left, I need to connect my position field. Should be this one. Yeah.
What's it called? To get position.
Where is it here? this. So now we've defined really a very stupid operation. It just reads out an internal state, gives it to the output, and we can read it out from the outside. Probably this will be something which we can auto-generate later on, so that you have some really simple operations like these automatically. But right now you have to do them, or have to create them explicitly. Anyways, now that we did that, we can go out to the root batch.
What position are we getting now? Like, are we getting the position that comes out of the reflective bound, the same as that one down there, or?
Yeah, we get whenever we call it, we get the position which was last written in there. So it depends which operation gets first. I mean, in this case, we only have the update which writes to the position. Yeah. You could have a more complex case where two operations write to the position. Then you have to know when, who is calling what and when.
Okay.
But anyway, in this case,
right now, this position down there is the same as this position up there.
Yeah. They all access the same field internally.
Okay.
This position writes the initial position here. This writer writes the position after the update is called, and this one reads the position whenever get position is called. Okay? Now, back to my first, I can now have a new node available. I can write get position on my main particle. I can connect it now. I put the position to the output.
Particle main or 2D?
Main, particle main. Particle 2D is the one which we got into the system by referencing this file from girl power.
Oh, yeah.
Yes. I got a problem creating the get position operation.
The get position? How to create it?
Yeah, because it appears, on the side, but I got nothing. I tried several times.
Okay. That's strange. We probably have to delete them. Can you press Ctrl Z a couple of times?
Yeah.
Just don't want, shouldn't allow such a thing. Okay, let's stay here. Now all you missed here was to also put this one on get to read the position when we put a get position.
Oh, okay. Okay, thanks.
Okay, now we have all these positions, and inside, before we do the update of the particle, we already have this acceleration pin, which is just the force we can apply to the particle. And also in the fetch by Björn, there should be this separate node. You can put it here.
Before you do this, shift it down a bit. How did the acceleration get in again? Okay. And you only did for each get position. Right? For each get position, that was the main thing so far. So I can repeat it here.
Yeah.
Okay.
Sorry?
Okay, now let's try to connect the separate node to our update particle.
What is the separate node doing?
I'm not sure yet why it takes in a velocity. We will see. In any case, it takes a position, one position, then it takes a spread of other positions. some other control parameters, and then it will output for that position a new in this case a force, yeah, a new acceleration. Depending on how near the other particles are, it will try to move away from them. Okay. Yeah, let's just now I have these multiple positions from the previous frame. I can put them in there to the other particle positions. And now I also need to get the current position of my particle again, sadly. Okay, so I have to do another get position here. My particle. Put it to the particle position. Now we also need the velocity. I will make it easy for now. I will just put the velocity here. Do another read. Velocity. Yeah, for simplicity, let's put it on the get update operation, because we can later call it split or something like that. It's just a simple operation where we just read the internal state of our particle, so we get it out somehow. We could call it, let's call it differently, let's call it just split, like we were used to probably in VVV, vector join and vector split. Yeah, just a naming scheme or a naming convention. Okay, now we can read out these two internal states.
Can you go back? Yeah.
Should I stay here for a while?
Yeah, please.
Okay? No?
Yes. Soon.
Everyone has the split? Managed to create the split? No?
But attends, mais change ça de nom. D'accord, ça c'est cool. Là, tu veux dire? Attends, output.
Yeah, that's okay.
Okay.
Okay, because I just renamed this operation in there, and our rename command is not that smart yet that it also renames all the references from other patches which we are calling this operation, so we have to do it manually. So we have to fix this error here. It's not called get position anymore, it's called split now. Just double click it, remove the get position here, press on the slow X button and then say split. And now you can also connect the velocity. And what else do we need? Yeah, here are some parameters we just put aside. Let's see. Yeah, I have to play a little, probably. Yeah, you'll see for yourself. Somehow.
Let's put some condition. I have a question. Why in the top of the for each loop, when you send the output of the first for each loop into the separates, why didn't you create this sort of inlet?
Yeah, well, the thing is, this kind of inlet,
Yeah.
same,
Yeah.
because the difference here is that if I create a normal inlet in a loop,
Yeah.
if you look at the tooltip exactly, it will show you the type, yeah,
Yeah.
of that inlet. And you see it here, the type is a particle.
Okay.
One single particle.
Okay.
And if I go up there to this second part of the pin, this
Yeah.
is the pin of the region outside,
Okay.
and the pad is inside. Yeah?
Okay. Okay. I understand.
And the pin in the region outside has the type a spread or a sequence of particles, so it's many.
Okay.
And inside it's just one. Because the loop does this looping
Mm-hmm.
over all these particles
Mhm.
and will call the body inside for each of these particles.
Okay.
So, okay?
Yeah.
This inside and outside.
Okay. I understand.
But in this case we wanted all the other particles, we didn't want to loop over them
No.
because the separate node has its own loop inside where it will loop over these other positions. Yeah. So it told us that it wants many positions, and the only way we can get it can put many positions to it is to just put the value from outside in there.
Yeah, so what it means is that it doesn't process the possession one after the other. It just receives a bundle of possessions and deals with it.
Yeah, it deals
internally.
with it on its own. Yeah.
Okay. Okay. Thanks.
Our lines here are all nice, but it doesn't do what it's supposed to do. So,
Did you play with the parameters a little?
yeah, we've got the same.
Not doing the same thing? That's sad.
That's the information you get from looking here.
If you reset the audio, try to rest it, try again. Why?
workbench.
Ah,
You
okay.
see?
Yeah, okay. Got it.
Connection here.
Yeah.
Yeah, I made it wrong in the first time. Yeah.
Ah, okay. Oh, wait. Got it?
Ok, c'est bon. On dirait un pâte fleur de sel. D'accord. Putain, c'est chiant. De quoi le séparer? C'est ça, oui. Et en deuxième paramètre, il a toutes les autres. Après, il fait sa sauce, je sais pas quoi. Démerde-toi. Putain, tu peux pas bouger les notes de clavier, c'est chiant ça. Et pour ralentir tes particules, il nous faut changer. Ah oui, parce qu'elle est en random la vélocité.
Does it work for everyone or no? Also not.
But it makes sense somehow that there is, because then those, every second is different, just one of them changes with the number of that are implied in this way. It's kind of hard to understand, but it makes sense.
Now can you separate the inputs from each other again? Wie kannst du die Inputs voneinander nochmal lösen? Wenn er zwei Inputs zusammen hat? Ja, ja. Zum Beispiel, also hier, diese beiden, wenn ich die zum Beispiel voneinander lösen würde, oder hier, ich habe das jetzt nicht kaputt gemacht, oder aber gerne Strom mit dem Input haben wollen.
10 mal 6, 6. Und jetzt rechtsklicken Sie. Du kannst auch, von dem, also wenn du es dir nicht weiter merkst, dass du einmal den Weg nehmen willst, dann kannst du auch an
Ich kann sozusagen direkt hier hingehen und sagen, das ist jetzt gleich ein Output, ja?
Just to show another little, just saw it. Just another little feature you can use. Sometimes you just take a value, initial value in your create operation or your constructor, then you are just done with it, and but later on you want to read it out again. And for example, we could add a color here. Let's say we take a color, some kind, and or let's make it, let's make it a color, and let's say on split, we also want to read out that color, yeah. So I create another output here. Hello. That's strange. Wait, I create an output, name it color. Yeah, super glitches here. Okay. Now what I can do, I don't have to, in such a case when I just want to take a value once and then I just read from it. Either I read an update from it or I read it out somewhere else. I don't have to create these writers and readers because I can just move from one color to the other, for example. I could just do something like this. And now the system will create an implicit field for me where it stores this value inside. So just to give you that hint that this is possible. This is only possible in these data type patches. These patches which are marked as a data type, which have an internal state, which can remember stuff. In these patches you can link from one operation to another one and remember something. Or remember the last value which was observed on the other operation on that hub. But anyway, I would only somehow recommend it for doing it for really simple stuff like from a constructor to update or to a split operation. So really for values you just read only once, or you write only once in your constructor and then you just read them. Otherwise it can get quite confusing and it's pretty easy to write something like a double buffer, then you get some strange behavior. So use that feature with care somehow.
Can you show me again how you created the color output?
The output?
How did you create the color?
I just double clicked. Yeah.
But you created it already in the orange section, right? Already in the split.
Yeah, I can. There are a few ways. I can take this link and I double click here in this area. Yeah. And it will create a path here and assign it to that layer already. The other way to create an output is to use the Node browser here and I say output.
And then assign it.
And then assign it to the layer you want to. What
Why it
else?
doesn't have a link when you create it inside? Why it didn't create a link like this?
It's white. That's why
It's
you
white,
can't
you don't
see it.
see it. I think it's a bad contrast here. Yeah. What I also wanted to show you is that we are not so. If I go back to the VVV patch. No. Nah, just.
Can you repeat the purpose of why you would add the color here now? What's the goal here?
I just wanted to show that you can link from one operation to another one.
In VVV.
No, that's coming now.
Okay.
I mean, we could patch something now. We could really write a color in, and we can do that, of course. We can go into the my first. We have a new bin here called color, so I can. Do we have RSL or something? And we could take these are all 0. You could also take some random value if you want to. Okay. So we just added a color field to the particle, yeah? It's just a random color now, but could be something else.
I think it's white.
It's white?
The HSL?
Yeah. Better now?
You want it 3.5.
I want it with just something.
The lightness is 1 in inches and it'll be a white.
Okay. And now it's black.
No, it's black.
So I take another.
You make it 0.5 instead. It should be color.
Thank you. Now I just could add other fields to the particle. Anyways, what I wanted to show you is that we are not only limited to this one transition here. So we can also output this particle here in VVV and do some route it through our patch and then split it somewhere later or call update somewhere later.
Into the center of the screen.
The VVV patch?
Behind your head.
No. What I showed yesterday at keynote, so basically it's like here we have our input devices, yeah, and we route them into VL, do some logic, and then we do the rendering. Okay, that would be simple, but maybe you need some other stuff and you need to route some data around, yeah, inside VVV. I just wanted to show this, that this is also possible. We just have to define a few more nodes inside VL, and then we can route the particle through VVV and do the splitting, for example, like reading the position somewhere else in the VVV patch. In order to do that, I have to, let's just say I want this split operation available here in VVV. For that, now I have to what? Yeah, well, now if okay, the naming is not good here. I should probably rename it. I will call it I don't know. Probably call it particle system, this one. So it's not called my first. And let's say we want to route all the particles of this system through VVV for some reason. Yeah. All we have to do is just take our particles and just create an output. This one, like double click, and just call it particles. Okay. And now I get this output pin here. This rather strange type called particle 4 RGB 14. Yeah. This name is kind of auto-generated by the system, but anyways, this is our particle, or this is our spread of particles now. And I could do, for example, a select here, select node, some stuff, whatever. Route it through my patch, and at some point I want to interact with these particles again. Now, in order to do that, I have to create another node for VVV. Right now I just have this particle system node. I also want a split node, for example.
What select
so
do we take?
What?
What select do we take? Sorry.
Node.
Select node, because this is not a primitive type for VVV. This particle is just the type we invented.
Okay, yeah.
When I renamed the node, when I just renamed the plugin, all the loops have gone grey and transparent, so they can't.
Yeah, then you have some kind of
It was broken.
error somewhere.
It was broken before, so what the hell.
J'ai pas pigé le truc avec le client. Putain. Merde, j'ai juste connecté un autre plus là. Ah, je vois pas. HSV.
Now, in order to get a new VVV node from inside of VL, we have to create a new patch. Just say add patch here. And now there are a few things. This patch has a few properties this patch has to fulfill in order to be a node inside of VVV. The first and most important thing is that it has to be in the category VVVV, okay? Like this. And then something else, call it my category, whatever. But it's okay when it's just in VVV. To make a node available outside, okay? So this is the first thing, and the other stuff is that I have to click all these checkboxes here. All of them. Yeah, that's because the hosting environment which loads the VL stuff, like it's written now, it just expects this, yeah? It expects that it is a data type, so it has a state, so it manages state. It expects that it's mutable. We can get to that later. And closed type means it expects that it's not generic, that all input pins and everything is defined. So for example, if I create an inlet here, an input, call it foo or whatever, and I create a plus, for example. Now, what I see is, it will complain now. It will say, I can't use this plus, because I can't infer the types here. Because I said up there, I said that the type has to be closed. There shouldn't be any parameters left anymore. Yeah? If I remove that flag, the system says this patch is okay. Because I didn't force it to be closed. I said it's okay that there are parameters in there, and once I apply this patch, based on the usage of the patch, the type will get inferred, right? Because when you look at it from the outside, you always have to have some data. You can't have T or nothing. You always have some data, so there will always be a type in there. Anyways, when we want to expose it to VVV, we can't have some kind of parameters lying around because our hosting environment would have to choose some unknown type for you. That's why we have to mark it as closed here. Now the system will complain about it. Yeah, just to show you that. In any case, we wanted to create this. We wanted to expose the split functionality of our particle. So I will call this input here. Will call it particle. And then instead of just a plus node, I will put the split node here. My particle. Then we simply expose all the. I always do the middle click. Double click. So that's funny. That's because of the color now. Okay. Yeah. Inside of the particle, we didn't define any data type for the color. Yeah. We just made a very simple thing. We just created this inlet and connected it with an outlet. The system says it's okay. It's just some random T6 or whatever, the type of it. This is okay inside our system because here we have the create operation and we connected an RGBA color to it. So our system was able to infer the type, or in this kind of usage of the particle, it knows, okay, it has to create a particle with a color in it. But in this batch here, we have this color output, and no one tells it what kind of data it is. And so we will have to be a little cautious here. So we can't really route data around which is still generic. In this case, our particle is still generic. We have this not colored pad here. You see it, if a pad is filled with the color, then it's a concrete type. It's a vector, it's a color, it's some other particle. But if it has a hole in it, then the type is unknown. And in VVVV we can't deal with such types. Okay? It always has to be something concrete, a closed type. It's very important. That's why we have to annotate the type here. If you want to use it, we have to write somewhere RGBA inside. And only now that this type has no parameters anymore, we can use it. We can make use of it outside of so in VVVV. Otherwise, it won't be possible. It's only a feature which you can use internally of VL. VL can deal with it, but we can't deal with it outside. Okay, this is probably a redrawing issue. Yeah.
In the util sub patch, I can't find the split.
Yeah, let's call it particle nodes. Utils is a little stupid.
Okay, because I thought you had to open the utils from the import menu.
I just created this. This was a new patch.
Okay. Okay, so I thought it was like dependencies, basics, this one.
Yeah.
It's not this one that you create.
No, I created just a new patch here. Yeah.
Oh, okay. It's called util. Okay, thanks.
No, particle node is not good. I should call it split. You see, now I have a particle node outside. This is the name which we will take outside. And now I have a particle node. Not the right name. We should call it split.
No.
So we have a particle split here.
No layer available.
And now, as you can see, you can now connect the. You should be able to connect this pin, the output pin of your particle system, where you get all the particles, and somewhere else in your VVV patch you can access these particles again and do the splitting, for example, or do some other stuff, whatever you like. Just to get you this idea. Is it working for everyone? No.
What's the category here?
Huh?
Right. Yeah, that's important. This category is I can also. The important part is that the main category is VVV. Okay, now there. We'll remove this VVV part and just yeah, but still I'm a little confused about the VVV.
Yeah, no, you had it as well in yours. You had it as well in yours.
Yeah, I'm still confused about it. No, also the thing about this category is the thing that we say it has to be in VVV so that we have a somehow clean cut between these two worlds. Yeah. If we would have allowed to be that every patch in VL is a node in VVV, then it would get kind of messy. So it's really important that you have this kind of separation where you know, okay, here's the moment where you step into the other world. Yeah. So that's why we are a little strict here and say, okay, please put it into that main category called VVV for your own sanity, yeah. So that you know which are the nodes. So for example, if I go over there in the main menu, it also has this sub menu entry where you see all the exposed nodes, yeah, all these patches which are available from outside.
Wie hast du die Operation genannt, auf der das liegt?
Was denn?
Auf der da.
Ja, das ist ja wegen dem.
Sorry, happened. You know, when we created the splits, we renamed it position. First it was get position,
Yeah.
and then but when I change that, it says it doesn't find it. How could I?
No, it says the pin get position was not found. Look, it's just an error message. But there was a pin. Yeah,
Oh, okay.
but it's gone.
Okay, but the connection still exists.
Yeah, because you patched it once like this.
Yeah.
And it won't throw away the information. Will it live in there?
Yeah.
And now you will. It just tells you, hey, there was a connection and there was a pin.
Okay.
And you know that you renamed the pin.
Yeah.
And you say, okay, it's fine.
Yeah.
So you take the new position pin.
This one?
No, this is an old one.
Oh, okay.
And it's just connected.
Oh, and then it goes away. Okay, thanks.
And then you should call it Node2015. Okay, now it should be ready.
No, it doesn't do anything now. There's no password to it. You go and look at the spread scan.
Because we have to data that it's not ready.
Lots of resetting. Oh, so you have this like node, yeah, and then you just get this one out basically. You know, and double click and get the split between. No, don't hit the one. The white. You see? And you don't have split yet. So what you need to do is this.
Yeah.
Yeah.
You reference this the same form.
So it doesn't call it. You didn't call it split. You have to look for reset. Yeah, yeah. Well, here.
Know what I mean?
Go here.
My first was this document VV where you
And
were
call reset.
like, okay, save
Yeah,
that.
and that's
Then you
your
created
that's
another
the
inside
you know what I mean?
function.
Like he
You
just
call
called
it
it
path
he calls
and now you open, I don't know how,
that you can
the
access it
util
and
sketch to another document, yeah? This document is not read. It should be read only, it shouldn't be download.
Come on.
But just because you bring it like
Non, je pense que c'est juste des catégories. Dans les DLL,
Now it's
tu peux pas les.
yeah, it should be
Les catégories?
It's just like how you get like those functions out.
now
by putting the select node.
Like you know what you want to do with the select node.
Dessus de telle ou telle manière.
No, that's the
Okay. I get what you're okay. It's something select node plus the split function.
yeah, that's the main thing. You have to remember that you can expose it.
Yeah, because I get it. But yeah, for example, it just
This is a category VB.
take it.
This is the most important thing so that our the VB or the host environment can see okay, this document also has
It
category.
is random, but you
As a node in
get a grid segment. If you would have got a grid segment,
these
like the
that
old
have
would
make
get
all
different
these
color.
Ouais.
checkboxes.
En fait,
This is just
tu
an
remplaces
indication.
les segments, tu
I mean,
remplaces
the
par
last
grid
one you will
segment
always have to make,
dans les
but
4.
it's best to just
Parce que segments, tu vois la différence?
probably
En fait, tu vois, segments ont le rôle d'être envoyé plusieurs triangles. Et quand tu vas envoyer une couleur, chaque slice de ton spread de couleur va colorer un triangle. Alors que grid segment, tu vas colorer la forme d'un triangle.
You know what I mean? So only with the segment you don't get you know it's just split
It actually just explains like the same time stuff. Sorry, because you spent extra.
Inside you have access to each part. Okay. Now you also have access to
For each place,
Mhm.
that region, you have the recursive possibility down the
Yeah, exactly. You can join again. Or you put the example right there. I think but you don't want it. You don't want it in this loop. You want it in this loop. Yeah, just like you put put it over there, yeah.
That's awesome. If you put the velocity on cycle,
I can also
velocity on cycle and the inner radius, the position of inner radius. What is going on? Okay. So you're checking out.
Next problem. Well, this is Node. So you need probably either you need a 2D version. You could, for example, fetch a 2D version from there. I can also start the vector position. Because the sample is defined on a float. And the position is a vector 2D. It's not yet. You have to do this explicitly. Either you write a sampler 2D, where you put a slip inside there, and then you always have this sample vector. I do it there. But we will. The next thing will be that we have for each component region. Yeah, it's basically just like the loop, but it will do it for each component. And once we have that, we can make the shifting feature. So you can select the sampler, and you say, okay, it's a float, but then I have a vector 3D. So you lift this into just a shortcut. You say just lift it, and you will put the region around it. You won't see it. You didn't know the type will change to a vector. The output will be a vector, and it will do it component-wise. So that's the idea how it should be, and I don't know, I hope we can get 2 months. So it won't be that verbose anymore when you have to do such simple tasks like getting out the positions, for example, just doing a sample read. When you do the connection, yeah, but it would have to be some kind of, I don't know, would have to do some kind of special shortcut or something, or the link would be, it would have to be some, as it would have to be annotated in short code. You would have to remember, okay, this you just did a lifting here or something like that. Otherwise, we can really use typing because the node says it is.
We put the other one in, this was typed and then propagated out.
I knew that I was doing something wrong. I tried, I know, no.
starting unit can come to like be endless. It could go much deeper into other parts of the project. But anyway, I wanted to show this example. So we can loosely start with but starting with outline. Okay, this was just to show you that you can also work with these types outside of the end.
So it's like drawing like inside this and then like this.
Yeah, this works as well. Here it starts like from down.
Start with the particle and start with yeah, but it's
Here
maybe the calculation, the separate calculation is just
parts and the parts
it's
here.
difficult. Learning a particle and it's difficult. But it's difficult to see it, yes.
This number is for each.
That's why it's really cool.
So we are calling this
Oh, but
this subgraph.
it just dropped.
This one is calling this one.
What?
Yeah,
It's like
calling this part.
so it's like this thing
It
is
just
called
dropped down.
here.
It's just point it blank.
So it's called
And I don't know why yours are very like
Yeah, this
fast
one
in the thing.
called
I don't know what you're saying,
this
but
one is called
look at mine, it always throw this shape.
this one is called
Whether we have
but also we also call for instance here, here, here.
You think that's the...
Yeah, it's totally up to you when you want to call it. You can call it
A million times.
and what about the other one?
I think it's really more can give you an interest
Yeah, there will be a book. Yeah, it's already online. Jorek, gut für online.
Nee, het läuft weiter.
Will.
Anyway, it makes always this shape. I think the thing is like... Why? Yeah, I guess it is.
C'est une seule particule.
Maybe he wants to play like, you know, this game where you
Putain, fais chier.
Do some stuff.
Oh yeah, they do.
Then you forget about it. See?
You don't know what type of
You're missing the right stuff. Current state.
Okay, let's use the project with here.
Then we have
We are running a special project with here. It's funny because when you look at this, this map will kind of sound old school, like it's so yeah, okay, that's fine, and that's good project. But I like the hosting project. I think this is
you tried undo?
Ah, it just took my phone. I didn't do nothing. Off.
Yeah, but this is now you have extend workshops and you can leave it up to the group.
I guess it will not show up the next time.
like, oh, you know, where for the next thing, then you're like, okay, what do I have to do?
Yeah, we were thinking about doing something like when you go to the timing mode, then you see something red. The slowest ones are red, so you see an actual. You don't
Yeah,
have
we
to.
have degree of red.
Yeah,
You know, like the red, like
yeah.
bright red.
You don't have to compare the values, but you get a visual idea of which parts